What was your motivation to write this 100-page book?
There were two groups of comments. One said, it's impossible. The other half of people commented like, oh, Andrei, please write it because I'm struggle with these books.
How your career has spanned through working at industry. Welcome to Ctrl+Alt+AI, where we decode the future of AI one conversation at a time. Well, I'm your host, Ishwara Srinivasan. I'm a data scientist and I began my career as a software engineer. I earned my master's in data science from Columbia University and have since worked across companies like Fireworks, Microsoft, Google, and IBM. Through it all, I've stayed passionate about simplifying AI and sharing practical insights with my community of over 500,000 on LinkedIn. Today, I'm excited to welcome someone whose work has guided thousands of AI practitioners, including myself, Andriy Burkov. Many of you might know him as the author of the 100-page machine learning book series, a staple for both beginner and seasoned professionals. Andrew has worn multiple hats, being a machine learning director, open source advocate, educator, and a thought leader. In this episode, we are diving into how machine learning landscape has evolved, what Andre sees as the biggest misconceptions in AI today, and what still excites him about the rapidly shifting field. We'll also hear his take on LLMs, AI safety, and where we're headed next. Thank you so much, Andre, for joining us for today's conversation. I'm super excited to chat with you. And as a reader of your book from the past, I'm so glad that we're chatting now.
Thanks, Ash, for having me. I'm really excited to our talk.
I've actually been following you much before I even came to the US and started my journey in machine learning. So I would love to talk to you about your journey, how your career has spanned through working at industry, in academia, in writing your book. So what really drew you into this world of machine learning and AI?
Well, it was partially actually just a chance that I've got because when me and my ex-wife at the time we moved to Canada, I didn't know what to start with because it was the first time I moved to a different country. So I didn't really know how to start, building something from scratch. So I decided that one good way probably to learn about how the country works is to study in the country. So I went to the local university here in Quebec City and started just a regular graduate program. And then I learned that, okay, they also have masters and PhD. And I was like, oh, it would be interesting probably to do some research. So I learned that you need to go and see like scientists, like professors, and if they like you, if they have some research topic that they want to give you, and also it was important for me if they have like a financing, some scholarships. So I went to several of them, and most of them told me, "Yeah, cool. I really like your profile, but unfortunately, right now I don't have money." And there was one professor who had money, and just by coincidence and by chance for me, the professor Brahim Shaibdra was the professor who worked on agents and multi-agent systems in the department. Nice. And he said that, oh, cool, like there is one topic that is getting hot. It's game theory. Because in multi-agent systems, each agent might have their own preferences about how the interaction should end. So in favor of this agent, or they will have a loss. So a multi-agent system seemed like an answer to this. The game theory. So the game theory says that, okay, for some situations, if you have different preferences, still you would rather prefer to act in some ways so that your opponent also acts in some predictable way. For example, everyone heard about the Nash equilibrium. It's like a concept that was mentioned in the movie with Russell Crowe, The Beautiful Mind. So he played the character of John Nash. It's an actual scientist, and he was the inventor of this Nash equilibrium concept in game theory. And my part of my PhD was about inventing algorithms how to compute a Nash equilibrium in any given game on a computer, because like the games can be very simple with only, for example, a couple of actions for each agent, but sometimes each agent might have thousands of actions. So how do you compute such a complex game efficiently was it still is a serious challenge in multi-agent systems. Yeah. So this is what
Interesting.
how I ended up in the AI field, and then once I graduated, I started to work for consulting IT consulting companies like Fujitsu, Gartner, and this is where I created a team for machine learning and started to myself, learn about supervised learning and supervised learning. But the initial knowledge came from my PhD on multi-agent systems.
That's amazing. That's wonderful. And I can totally see, like, what would have inspired you to like become an author. So I'm particularly intrigued by your 100-page book. I have gotten one of your copies of the 100-page machine learning, but then I'm just glad that you sent me the language book. This is your newest book that you have. So I'm curious, like, what was your motivation to, like, write this 100-page book, and like, how did you go about it? What was the thought process?
Well, the first book was again, I might say a
Yeah.
chance, because I started to be quite active on LinkedIn as they call it influencer. Well, I don't like the term, but let's use it. So I posted a lot about everything AI, machine learning, and stuff like this.
Mhm.
And it was 2019, so way before the current jump in popularity of the field. So in 2019, the field was still quite niche and mostly used by academics or some, like unicorns like Google. Everyone knew that Google uses some AI
Yeah.
in search. No one knew exactly what it means, but it sounded cool. So I started to learn about it myself. So
Mhm.
I bought a bunch of books and quickly realized that I'm not capable of reading all of them. Like it's just too much, because those books
Yeah.
were for these were textbooks.
Yeah.
So they were written by academics for academics or for their students. So like it was the books were very dense in math without too much words. So like just one equation follow another one. And it's okay, because if you are an academic, you are supposed to understand it. If you are a student, you are supposed to knock on your professor's door and say, "Oh, okay, I would like to understand why this follows from that."
Yeah. Yeah.
So I decided that okay, there is a so these books are just too hard for regular people to enter into the domain, and I saw the interest among my audience on LinkedIn at the time to kind of uh, get some understanding of the field. Like, what does it mean to
Yeah.
do machine learning? What is gradient boosting or random forest?
Yeah.
No one actually knew. So I just posted like this by saying that okay, all books that you currently can buy about
Yeah.
machine learning, they are too thick, so no one has time to read them. And even if you had all the time you don't have access to a professor. So if you are blocked, you are blocked.
Yeah.
And I wrote just for fun, like if I was to write a book on machine learning, it would be maximum 100 pages,
Yeah.
because in my head it was quite clear, because I spent time still reading these books, and I understood like how it works,
Yeah.
neural networks, tree-based algorithms, support vector machines, and so on. So
Mhm.
in my head it was quite clear. And I was like, why write 1,000 pages if you might write it in 100? And when I made this post, I didn't have any idea about really writing this book. I was just saying that someone has to write this book
Yeah.
because it's possible.
Yeah.
And people the post has become viral on LinkedIn, and people from all over the place came to the comments, and there were two groups of comments. One said, it's impossible. If it takes 1,000 pages, it's because you cannot explain it better, like shorter than 1,000 pages. Otherwise, why everyone
Yeah.
wouldn't write such
Yeah.
small
Yeah.
books? And the other half of people commented like, "Oh, Andrei, please write it because I'm
Yeah.
struggle with these books,
Yeah.
and I really need something smaller and easier to read."
Yeah.
So I took it like as a challenge. So you challenge me, you tell me that
Yeah.
I posted this and I cannot deliver. I will deliver. So I wrote it, and I managed to fit into this 100-ish concept, because it's 100, I think, 46 or something like this pages, the first
Nice.
book.
Nice.
But I
That is
kept the
cool.
title. Huh?
That's very cool. That's very cool.
Yeah, so I kept the title because it was the title that I think was self-explanatory
Yeah.
and fun, and this is how it's happened.
That's wonderful. I mean, like, I've been following you, as I was telling you, like, I've been following you for quite some time on LinkedIn, and I've always appreciated your perspective. I've always appreciated the non hype explanation of stuff. And the other thing that I personally love about reading your posts is it's always challenging one of the norms, like people, this is very common in the AI space. And I've personally seen this as well, where once a lot of people start talking about something, like let's say, like, the top 5 or 10 people just start talking about something, the rest of the crowd just follows, and they're like, oh yeah, like, it's always like plus one, we agree, we
Mm,
agree, we agree. Nobody really challenges that concept. And one of the things I loved reading about your post, in one of the posts that you've mentioned, is like the current LLMs lack the true agency, right? Like, it's currently still not as sophisticated as it should be in order for it to be deployed in real world application. The real agentic behavior has limitations, and currently we don't see it at the extent that we should be. And that is one of the reasons why none of the companies or enterprises that we see are readily using these general tech models, like the general intelligence model that's available out of the box, for their use cases. There's a lot of fine tuning, there is a lot of customization, there is still a ton of low level of autonomy, because of this
mm.
reason that the true agency is still not as sophisticated. So I loved reading that perspective from you. So I would love to hear more about that. Like, what do you see? How do you predict this agentic behavior is really going to change in the future? How the research and like the academia and industry has that gap? Like, what do you feel about that?
I think there is a lot of misunderstanding about what an LLM is. Okay,
Mhm.
so for someone who just use it, or even builds with it
Mhm.
without really understanding kind of what it is behind the scenes, it might seem like, okay, it's kind of an intelligent entity
Yeah.
that becomes more and more intelligent as the companies release larger models trained on more data, and eventually this intelligence will just catch up a specific level that we will feel like, okay, it's already good enough for us to 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 work with it as if it was a human being of some intellectual capacity. But this only comes from the fact that you don't understand exactly what's going on inside. So once you really, becomes familiar with the mathematics of it,
Mhm.
and overall, like with mathematics of how neural networks learn,
Mhm.
you actually understand that there is no intelligence inside the model. The
Yeah.
intelligence is in your head, in how you interpret the text that the model generates. And to come to this understanding, it liberates you from making this mistake of taking this for some intelligent entity. So I give you an example. So if you take a small model, small LLM, I don't know, today small, it's let's say 100 million parameters,
Yeah.
and you train it on some data set. Then you ask it questions. It will not even understand what to do with your question. It will just generate some random text. So you say, okay, I will train a larger model, let's say 1 billion parameter.
Yeah.
So now you ask it a question and it kind of tries to answer the question, but you still see that it doesn't make much sense. And then you increase the size more and more and more. And the larger the size, the more you're convinced that the text becomes intelligent. So the model doesn't really becomes intelligent. It's your interpretation of this sequence of words that because we are, we are social species. We interact, and for us, the way of interacting is to talk or by writing. So we send letters here and there. So when we are faced with some sequence of words, our brain is wired into interpreting it as written by some human being. So this is how nature and natural selection made of us good readers and good writers.
Yeah.
So when you see just a random number of words, your brain tells you something is wrong. It's not a coherent text, and you are like, it's not really a coherent text. But then when you increase the size of your model, the text, the sequence of words becomes more and more similar to how people write. And why it's that is because, we give it a lot of examples of human writing, and we give it a lot of parameters so that it can remember how to place this word if it's preceded with this word, or how to place this word if the sentence started with this word. Why it learns to do it? Because the loss function in this model penalizes the model for not predicting the right word in the right context. So the more parameters you give it, the better the model will avoid being penalized. So at some point, the sequence from your human perspective becomes so close to something that a human being would write, then your brain stops saying something is wrong. The brain is convinced now that it was human written. And after this point, many people start thinking that, okay, if I read it and it sounds like a human being, then it's as intelligent as human being. But no, it just hacked your internal kind of detector of random word sequences. Now that your detector is hacked, they can give you any model they want, and you will just take it as oh wow, it's even more intelligent and more intelligent. But in reality, it's just that it hacks you in this domain, and now it hacks you in this domain. But it doesn't become gradually intelligent as we think of children. Okay, so a child is born, they cannot really write, and then they write one word and then 2, 3 words. But the child eventually learn the concepts of the physical world. And when you ask a child about a specific concept of a physical world, the child thinks about this concept and then transform this thinking into words. An LLM doesn't do it. If an LLM needs to learn some internal representation of some concept in of a physical world, it will learn it just enough to fool you into accepting this sequence of words as something intelligent. No, not more than that. So we can try and throw a lot of data into it and increase its parameter size, but it will only learn to fool you where you are able to penalize it, and where you cannot penalize it, it will just leave it as is until you actually use the model and see that it generates some garbage, and you are like, oh wow, you were just so you were just so intelligent 5 minutes ago, and I asked you kind of a similar question. What changed? What changed is that it's now what we call out of distribution. So you ask it some question that wasn't in the training data, and it fails.
I can't agree more. And I love the analogy that you used, right? And I had actually posted about this a while ago, that we are trying to keep on thinking about like this AGI. But one of the misconceptions about AGI is also that it's going to match up to human intelligence. That is not the case. As you rightly pointed out, right? Like there is a lot of ways, one, how humans learn. We interact with the physical world. We uniquely respond to situations differently, and that's what makes us human and have like a human intelligence. One kid would respond to a situation differently than the other, and the reinforcement that they have, or like the environment that they are learning from, really shapes their personality. It shapes their intelligence and how they grow up. So human fundamentally, how AGI is supposed to be, is not anything to do with human intelligence. And I feel a lot of people like try to confuse this, and they're like, oh, like, can you replace an entire human being who's an expert in, say, software engineering or like legal, with an AI which has reached the AGI capability? I think that perception itself is wrong. Second, I love the fact that you mentioned that, like, summarizing that you just mentioned, right? Your model is only going to be as good as the benchmarks that you're testing it on, right? Like, what you have not tested it on, it has not improved on.
Yep,
So
and this is how these companies, LLM companies, we might call them today, like OpenAI, Anthropic, and so on. They say, okay, our new model is better on this benchmark and this benchmark and this
yeah,
benchmark, and people kind of extrapolate this. Okay, so if on all benchmarks it's better,
yeah,
then even off or outside this benchmark, it's also better, because,
yeah,
well, you cannot be so lucky that you take some random 20 benchmarks and everywhere is good. The thing is, they are not random. So
yeah,
they actually target those benchmarks
yeah.
so that they beat the previous best result. So
Yes.
this is not how the benchmark must be used. And in science, the benchmarks exist to measure a progress in some field. But if your measure of success becomes beating this benchmark, you will forget everything else. You will just target on this specific benchmark, you will
Yeah.
beat it, and you will claim like, see, I beat this benchmark, so you can take my LLM and
Yeah.
use it everywhere. No, I can use it where this benchmark falls and maybe where
Yeah.
some other benchmark falls, but
Yeah.
like between these two benchmarks, it will just extrapolate some hallucination, and that's it.
100% agree. And yeah, I think that's very important for people to understand that because a model performs on certain benchmarks, it doesn't mean that it has gained that level, or like, the next step towards AGI. Just because it's grown up like by 5% across all benchmarks doesn't really depict that. It just means that you have fine tuned your model to be better at these results, or like these metrics that you're trying to track. But then when it goes outside of that domain, you don't know how it is going to perform. And that's the part about AGI, right? Like, if we are really talking about AGI, then it should not be limited to just 20 benchmarks.
No.
So
But first of all, the concept of AGI depends on each person you talk to.
yes, yeah,
And if you talk to Sam Altman, we pronounce it Sam Altman. They, when they signed the contract with Microsoft, they defined AGI as a model that will generate $100 billion in profits. Well,
yeah,
okay, yeah, it's your definition. You have a right for it, but is it a definition that everyone else has in mind? I don't think so. So some people define an AGI as a model that can perform tasks that a human performs with the same level of success or even better. And then they test it. They create a model and say, okay, let's test it on how they pass this bar exam for lawyers,
yeah,
and it passes, and even better than the average of students. They say, you see, now it's much more intelligent than a regular lawyer. No, because a regular lawyer in their real work, they don't pass exams. Exams were invented as a proxy to
Yes.
kind of for a school to be sure that you understand something about your domain. So
Yes.
these exams, they test a tiny chunk of what a regular domain of a lawyer expertise should be. But again, we talked about benchmarks. It is a benchmark. It says, if I randomly pick this question and this question and this question and this question, and I show it to you and you answer them, then I can kind of be sure that you understand the domain as a whole. Because I randomly picked those examples, those questions, you couldn't know what I will pick for the exam, right? But now they take all the questions they were ever asked on those exams, fine tune the model on them, and then they say, okay, now I show you some similar examples and you are supposed to
Yes.
answer them.
Yeah.
Of
Yeah.
course it will. You gather it exactly, the subspace of something askable on an exam. But
Yeah.
in real life, there are many more situations that are
Yeah.
just not askable on an exam.
Yeah. Absolutely. 100% right. And I feel like to some extent it's ideal case should be treated as a co-pilot pretty much for everything, the same way that we treat AI models as a co-pilot for coding, a co-pilot for writing. I still feel like I personally at least see AI tools that way. Like it helps me be more productive rather than replacing any particular role itself. But I do understand that, yeah, like to some extent, there are certain roles which have been heavily reliant on um, non-stakeholder management specific roles, or like non-relationship building roles, which can or may be replaced by certain AI tools. But then I see the space evolving into newer roles. Like, for example, a lot of times I hear that, oh, data analyst role is dead. Because now your model is able to crunch data, it is able to like build plots, it's able to do a better job than what a human could do on Tableau or something. So, data analyst role is dead. I would say it's not dead, it's transformed. Like people who are still doing data analysis are going to be using AI tools and focus on something different, and like have AI as their co-pilot to help them with certain tasks. Again, these
Mhm.
AI tools are not AGI, but they are specifically built, or like purpose built AI tools.
Yeah, and well, I think that the job of a data analyst is the one that I really, I think that people who call themselves data analysts, they
Mhm.
benefit the most from the modern AI. Why? Because previously they had to write all those pandas script by hand. It's not really a
Yes.
big pleasure to do it.
Mm.
But
Yeah.
now you say this is what my data looks like, and I want to know the trend for this variable given that variable.
Yeah.
And the LLM will just write you the Python code that will manipulate your data in the right way, and then even create the right Python code that will generate the plot.
Yeah.
And you just by talking to the LLM and by explaining what your data looks like, you
Yeah.
get your data analysis, like the entire report. So from my perspective, the job has become much more pleasant. But of course, because now you don't need to spend an entire day to code this pipeline by hand, and you spend maybe 5 to 20 minutes to communicate with an LLM and you
Yeah.
get your working Python code. The
Yeah.
question is, how many data analysts we need if one data analyst now
Yeah.
can do the job of 25?
Yeah. Yeah.
So, and this is the question, not really easy to answer, because like the first instinct is to say, well, if one person now make the work of 25, then the 24 will be laid off and they will go live on the street. But on the other hand, previously very few companies could afford hiring a data analyst
Yeah.
because they were expensive.
Yeah.
And let's say you are a company of 10 people and you have a choice. You can hire a salesperson or a data analyst. most likely you would hire a salesperson, so you will remain blind about the data that you sit on.
Yeah.
But now, because one data analyst can now work for many more projects than before, then you can hire a part-time data analyst that will work for you, I don't know, an hour a day, and they will work also another hour for another company. So in
Yeah.
this case, many more companies would hire data analysts that wouldn't hire them at all in the past.
Yeah.
So maybe, and I think that the history of our society and the history of invention usually shows that when you create some tool that increases your productivity, this results in a temporary loss of jobs, but then
Yeah.
those people
Absolutely.
who lost jobs get hired because now doing this has become accessible for many, like cars, for example. It all started with only rich people who could afford the car. But then Ford invented the conveyor, and building cars has become much cheaper. And a lot of people now could afford this car. It's the same for companies.
Yeah.
Previously, doing AI was expensive. You could not do it, but now anyone can do it. So you can
Yeah.
hire someone for not very expensive and do it. So we will see what wins. But usually the progress creates jobs rather than killing them.
Yeah, absolutely. I can't agree more with you on that. And I'm curious, like, what your thought process is, and because you mentioned, right, like, with all of these models, there is a true democratization of AI and what AI can do. Because so far, if you think about it, like until 3 years ago, nobody had access to all of these sophisticated AI tools. Like now my mom can just go to chat gpt and like she's technically using one of the state of the art models to do something for herself, but that
Mm.
accessibility used to not be there, and now she has access to it, one on a free tier or on something which is as cheap as $20 a month. So that level of accessibility was not there, and now with that sort of democratization, I feel a lot more can be done, a lot more new businesses can be created. Anybody sitting in like one of the remote cities in India, like I always feel that, right, even with social media, that's what happened. I see so many people sitting in remote villages, in remote places, in small cities and underdeveloped countries, but they're still able to make a living out of just having that one social media thing. Like, they have
Mm.
access to internet, a phone, and that's it. Like they can do a lot, they can learn a lot from the internet. And now that's become plus plus with chat gpt and tools like that, which gives you access to more intelligence. So I like to call it as like intelligence as a service, because essentially that's what it is, in different form. I want to get your perspective of how you see this space evolving from like an open source perspective as well, because the earlier players were all proprietary models, including OpenAI models, Claude models coming from Anthropic. How do you see like OpenAI has started having an impact, and what do you think like is going to be the future of using OpenAI in this enterprise setup?
Oh well, it's a lot of things to talk about in one question. So the first thing, so you call it intelligence as a service. I call it a professor as a service. So
Okay.
let's
Yeah.
say, and I don't again, I don't say that it will replace professors. So
Yeah.
the idea is the following. Let's say you live in a small town somewhere, far from large cities like New York, San Francisco. So you don't really know anyone involved in any university or in any technological company, but you
Yeah.
really like to tinker. Okay, you like to build stuff, but you don't have knowledge. You don't have education, and it's a common situation for many folks. So you want to do a lot of things, but you don't know how to do it, and you don't know where to learn it from. And if you talk about books again, they are thick. They require some like initial knowledge to understand. So many people just lived their lives in the past
Yeah.
wanting to do stuff, but not capable because no access to what I call to the professor. But imagine if all of these folks had a number in their phone where when you have a question about some domains of your passion, you call the number and it's your, I don't know, your uncle who is a professor in this domain, and you say, hey, I would like to build this stuff. What are the main steps? Like, where do I start from? I will figure it out. Just give me, like the direction and the recommendation, like what to avoid, or what to do differently. And imagine this professor who normally charges like $500,000 an hour. They answer your phone and they say, yeah, I know. Try this, try that. Go to this store, buy this piece, and you will be good. Imagine if every one of us had such a professor on the phone. Our civilization would be totally different today. But because professors are not someone who you usually have on your phone, this was the case only, like this possibility was the case only to students who were enrolled in some universities where this professor were available. Or very rich companies who might purchase the expertise of these professors and so on. So today, this professor is available to anyone with a phone. And I don't say that this professor is always right. And many of those folks will talk to ChatGPT or any model, and they will give some advice. They will follow the advice. They will fail. It's okay, but at least they tried. And maybe even if, I don't know, 6 out of 10 folks received some guidance from this professor and succeeded, this might result in a new Apple, in a new Google, in a new IBM, Microsoft, whatever, Tesla. Now, today, you can talk to a chatbot and it will explain how to build an electric car like from scratch, because this information is now available online. So it was trained on it and so on. So this is the first part of the question. The second part of the question, like open source versus commercial. I think that for many use cases, having a local model will still be a necessity. So sharing the proprietary data is a challenge for many companies, especially large companies. I worked for Gartner. The first thing Gartner did when ChatGPT was released 2.5 years ago, they forbidden using ChatGPT for the entire body of their employees. Why? Because first of all, it's this fake information or hallucinations would find their way to Gartner's report. So it's a huge like image danger. And the second thing is that Gartner owns a lot of very proprietary information of their clients. If you start feeding this information to someone like OpenAI or whatever provider of closed weight LLMs, there is no guarantee that you don't share this critical data with some competitors. Like we all know that everything we share on social networks is getting analyzed by those algorithms. Like even if your post is private, Facebook or whatever company, they still use it to sell you, I don't know, tools or TVs. So what is the chance that you will ask something ChatGPT about? You will provide some proprietary information, and this information will not be sold to some client of OpenAI who says like, if you have a conversation about this domain, I would like to pay you big bucks to read it. No guarantee. So this is one important reasons for using open weight domains, because you can run them locally. However, the problem, at least today, maybe the technology will change, but today, if you want to run a competitive open weight model on your own infrastructure, you will need quite an expensive infrastructure. So, for example, if you want to run a model of more than 40 billion parameters and even smaller, you still need this, top GPU that currently I think costs around $50,000. And if you want to run a model like, for example, DeepSeek R1, well, this one is 600 billion parameters. So to run it, you need at least a couple of nodes, I think. So a node, it's like a computer with eight GPUs. I'm not sure that DeepSeek fits on one. Maybe it does. But one such node will cost you. So it's 50 times 8, almost $500,000. Or you can rent it for about $150,000 a year. Very few folks can afford something like this. Very few companies can afford something like this. So for this kind of clients who are not big enough, this closed weight models is a viable solution because you pay per token, and tokens are cheap. So there will be market for both, I think. But eventually, as I said, like the price of those GPUs will go down because when you produce GPUs, it looks like 3D printing. So you print layer by layer or these chips. So currently, very few companies have the know-how to do it. Google is one of them, NVIDIA, AMD. But because it has become such a big necessity for society, it's just a matter of time that the technology becomes available to more than 3 companies, and people will be able to acquire large enough equipment to run large enough models. But I don't know how fast it will be. Today, it doesn't seem like prices fall fast enough.
Yeah, absolutely. Yeah. Totally agree. And yeah, I'm also hoping that it gets like more democratized in that form where it's not just the layer which is building foundational model also gets larger and larger. Right now I feel it's very, 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 very tiny, concentrated in the hands of few. um, so while we're talking about it, like, we spoke about a lot of different things, capabilities of LLMs, like what are the parts that they have a bottleneck with. So what would be that one thing that you wish AI could do today which right now models can't do?
Well, I just recently posted about it because I'm in the middle of working on my own kind of pet project that I
Yeah.
hope to be able to release soon enough. And I do it using I code. It's a web application, and I code it using language model because,
Okay.
well, I'm no expert in React, for example.
Yeah.
I know JavaScript because I 20 years ago I coded JavaScript like vanilla JavaScript by hand, but that's it.
Yeah.
But today, if you build a modern web application, usually you choose some framework because you don't want to
Yeah.
rewrite all this code over and over again. So I chose React. Why React? Because it has the largest presence in the training data for those models. I really would prefer something else, like Svelte. For example, a lot of folks recommend Svelte as a good framework for modern web applications. But Svelte has a very tiny presence online, so I just fear that if I start with such a less popular framework, the LLM will hallucinate all the time, and I will never finish my application. So I chose React. So what is the problem? The problem is that when you start, it goes super well. Like you just ask, I want this application, and I wanted to do it to be able to do this major feature. And when you start from scratch, you get your code like this. You implement it. You click play. Well, you run some start command on the terminal,
Mhm.
and you have your application.
Yeah.
It works like this right away, and then it motivates you so much that I started to sleep for at most 6 7 hours because I just cannot stop adding new features. It's
Yeah.
so addictive, because like previously, to add such features, you would need a team of developers, and they would say, okay, let's scope it. Okay, it's scoped. This T-shirt size. Okay, this one will take 2 months. This one will take for 2 quarters. But now you just say, I want this, and you get it in 3 minutes. It's super fast. This dopamine cycle, so it gets addictive. So now my code base approaches 150,000 tokens. And this is where it all starts to get ugly, because when your code base is this large, ChatGPT just refuses to take it. It says your input is too long. You have nothing from it. Claude it has a limit, I think, of 260K tokens. So you still can put 150 in it. But then it starts thinking. And it thinks and it thinks and it thinks. By adding those thinking tokens to your token count, eventually it reaches 260 and says, you reached the maximum size of your conversation. Too bad. So again, nothing. So what remains is Gemini 2.5 Pro from Google with 1 million token context. But Gemini is not the best, the smartest of the models. So first of all, and second, even if you paste 150K tokens into this model, these models weren't fine-tuned on a lot of good quality examples of such large code bases, because, well, to fine-tune it, you need to create this code base, and you need to kind of simulate a conversation between a person and this code base, and the person would say, I want this feature, and this doesn't work, fix it. So it's very hard to create such high-quality examples that consume so many tokens. So my what I would like to have today is a Claude quality of programming in a model that supports at least 1 million token of context. But I think that it will be very, very hard to achieve, first of all, because it will be very expensive to train such models. Imagine supporting 1 million token context. So again, if you know about how this model works. So if you have 1 million tokens, and in Transformer, you need to compute these attention scores between each of the tokens embeddings. So you need to multiply 1 million by 1 million. So it's like 1 with 12 zeros dot products. So it will never fit on 1 GPU, not on 2, even not on 100 GPUs. So they chunk this long input into small pieces, and each piece is computed on a large array of GPUs and then combined. So only very large companies like Google and maybe, I don't know who else can afford.
Meta has launched, right? Like Meta's Llama 4 Maverick has 1 million context window, and Scout is a smaller model, and that has 10 million context window.
Well, the fact that you tell that it has, it doesn't mean that it can use it, because supporting a long context it's not a mathematical challenge. Mathematically, this positional embedding that we call rope. Okay, this is an algorithm that assigns to each token its position in the sequence in the transformer. So with rope, you can train your model on a short context, and then you just change one parameter in your rope algorithm, and it expands the context to basically any size you want. The problem is that, first of all, this expansion doesn't mean that even if your model now understands that this token has the position 1,300,025, it doesn't mean that the model knows what to do with it. So, for example, companies, to show that their models actually can use this 1 million or 10 million context, they use the test they call needle in the haystack. So basically, they put this very long input that consumes all the tokens, and in this input, randomly, they inject some small piece of information. And then they test the model by saying, this input contains some information about X. Find this information. And the model says, yes, I found it in position XYZ. This is it. So they say, oh, cool, it supports 1 million or 10 million token context. Well, it supports for the needle in the haystack. But will it support if you want to fix some very large application that you paste entirely in your prompt? I really doubt it. So it takes really examples of this size crafted specifically by people who know how to fix such software. They use reinforcement learning recently a lot, and this is probably for me like one hope that even automatically you can support such long context, because if you paste such a such a large application in the prompt, and let's say you hide just one class or one function of this application, and then you replace this function with just verbal description of what it does. So if you then train your reinforcement learning model with the reinforcement learning to reproduce this hidden function based on its verbal description, and you can automatically test then that when you build the application, this function actually works. Then you provide the positive signal to your algorithm and training algorithm, and it might learn something very, very powerful about this long context. We will see. But for now, just claiming that you support it doesn't mean that you can do anything with it.
Thank you. Thanks for sharing that perspective. I'll definitely dig deeper into it. I have access to the Llama 4 Maverick with 1 million context, so I'm definitely going to play around with it to see other examples that you just mentioned and see how it performs. So thanks for sharing that perspective. And one last thing I would love to learn more about. I love your book. I've just been curious about what is that one book that really inspired you. Like, it could be a machine learning book, it could be not a machine learning book. What's that one book that you really enjoyed?
Um, I know most of the time during my last 18 years as a dad of two girls.
Yeah.
I read children's book, and I think that the one that really affected me and made me really feel about it was The Little Prince
Okay.
of Exupery, and I actually put one quote of from Little Prince into my books on language models.
Oh,
That
lovely.
says
Okay.
that one of the characters in the book says that language is a source of misunderstanding, and I think that it resonates a lot with the book on language models, because yes, well, you can train a model that generates something that looks like human written, but it leads to misunderstandings many times. So yeah, and I like Little Prince because it talks about us as a society and all the different flows that we as humans have, but in such a magical and subtle way, so even children like the story. So I think writing a good, like writing a book for children such that even parents feel something about it. It's a gift, and I really admire such books when I find them.
That's lovely. Well, that's lovely to as a recommendation. I'm sure a lot of people who have kids would relate to it. And thank you so much, Andre, for joining my podcast. And thank you so much for sharing this book. I loved that you wrote a small note here. So thank you so much for that. And also very fascinated to to see Windsurf's quote at the back of the book. It must be a really fascinating read. I haven't read it yet, but it is definitely on my list. So would read it and definitely share my thoughts on LinkedIn. But thanks a
Yeah.
ton for joining me here. It was lovely talking to you, and We very quickly exhausted our 1 hour without even knowing. Like, I would have probably wanted to talk to you more. But thanks a ton for joining me today.
Thanks for having me, Ash. And once you read my book, maybe you will have some additional topics you would like to discuss. So let me know. Maybe we will do another podcast
Yes,
next year or
absolutely.
something
I
like
would love
this.
to do that. I would love to do that. Thank you, and thank you, Andre.
Thanks.
Well, that brings us to the end of a truly insightful conversation with Andrei Burkov. Whether you're just stepping into the world of ML or scaling your second AI product, I hope this episode left you with a fresh perspective and tangible takeaways. You can find the links to Andrei's books below, and other talks and references will also be added there. If you enjoyed this conversation, hit that subscribe button and turn on the notifications. We have a lot more trailblazers from the AI world who are going to join us soon. A huge thanks to Andre for bringing his clarity, candor, and curiosity to this show. Until next time, stay curious and keep decoding the future. This is Control Alt AI. I'll see you next time.